Chapter 10, Question 7, says to indicate whether each of the following solutions is acidic, basic, or neutral. And what they do is they give you concentrations, that's what the brackets are telling you, of either H3O plus or of OH minus. And then they give you some number for the concentration. So what you would want to remember in order to assess these concentrations is that neutral is when you have 1 times 10 to the negative 7th H3O plus and 1 times 10 to the negative 7th OH minus. So that's neutral. Now, we're going to compare the information they give us to that. If it's equal to that, then it'll be neutral, and if it's higher or lower, it'll be acidic or basic. So when you're thinking about it, the first thing you want to do is ask whether you have an acid, and the acid would be H3O plus, or a base. So that's the first question you want to ask yourself. Are they giving me information about an acid or a base? Okay. Now, if it's an acid, you would want to ask yourself if the number they're giving you is more than 1 times 10 to the negative 7, or if it is less. Less than 1 times 10 to the negative 7. So if you have more acid, it should make sense that that would make the solution acidic. But if you had less acid than neutral, then it's going to be the opposite of acidic. It's going to be basic. Okay, then you go through a similar analysis for the base. If they give you more base than neutral, more than 1 times 10 to the negative 7 molar, then you're going to have a lot of base in the solution, and the solution will be, basic. But if you have less base than neutral, which is 1 times 10 to the negative 7, if you have less base than neutral, then it's going to be the opposite of basic, which is acidic. So you have these sort of 4 scenarios. First, ask yourself, are we dealing with an acid or a base? Then ask yourself, is the number bigger or smaller than 10 to the negative 7? And that will lead you to a description of the solution. Okay, so for A, for example, they give you H3O plus, and we can see from that that we're dealing with an acid. Then let's look at the number. The number is 2.0 times 10 to the negative 5th for A. So let's just write that out so we can see something. We want to ask if that's bigger or smaller than 10 to the negative 7. Remember that if you have a negative sign, you're moving the decimal to the left that many times. So 1, 2, 3, 4, 5. So we'd have 0.0002. 10 to the negative 7, that's 1 times 10 to the negative 7, that's going to move it over 7 times. 1, 2, 3, 4, 5, 6, 7. So you can see that the number on top, this exponent here, because it's negative, it tells you how many zeros are going to be in front of that number. And you can see how 10 to the negative 5 has fewer zeros than 10 to the negative 7. So 10 to the negative 5 is more. It is bigger. 10, well, and I should say 2 times 10 to the negative 5th is bigger than 1 times 10 to the negative 7. And I know at first glance that might look a little confusing because you'd say, wait a second, 7 is bigger than 5. But remember, that exponent is telling you how many zeros go in front of this first number. And if you only have 5 zeros in front of it, that's going to be a bigger number than if you had 7 zeros in front of it, like we saw here. So, okay, so keep that in mind. Okay, so we had more acid, and that means that we said, okay, we have acid, we have more, so that means the solution is acidic. So this is acidic. Okay, for B, first ask yourself, are they giving you an acid or a base? They're giving us H3O+, which is an acid. Okay, next, is 10 to the negative 9th, 1.4 times 10 to the negative 9th, bigger or smaller than 1 times 10 to the negative 7? This has more zeros in front of it, so it is smaller, which means you have less. So we have less acid, okay? We have acid less, the solution is basic. Okay, OH minus, acid or base? OH minus is a base. Second, is the number they're giving us bigger or smaller than neutral, 10 to the negative 7? And because it's 10 to the negative 3, there are fewer zeros in front of it, so it is actually bigger than 10 to the negative 7, which means you have more of it than neutral. Okay, so we have base more, so base more, solution's going to be basic. And for this last one, first identify whether they're giving you an acid or a base. Here they are giving us OH minus, which is a base. Now we want to ask ourselves, is this number they're giving us bigger or smaller than 10 to the negative 7? Because the exponent is negative 10, we have more zeros in front of it than 10 to the negative 7. So it's going to be smaller. Which means we have less of it. Now if we have base less, so less base, it's going to be base less, solution is acidic. So this will be acidic. If you have less base than neutral, then the solution is the opposite, acidic. Okay, so that's question 7. Now question 8 is really the same thing, so we'll practice a little more with these. Here, first thing we want to ask ourselves is, are they giving us an acid or a base? They give us H3O+, that is an acid. Next, is the number bigger or smaller than 10 to the negative 7? Because the exponent is negative 12, we have more zeros in front, which makes it smaller. So it's smaller than 10 to the negative 7, which means we have less of it. So we have less acid than neutral. Less acid than neutral, acid less, that means the solution is going to be the opposite of acidic, basic. So this is basic. For B, first thing you want to ask, are they giving us an acid or a base? They give us H3O+, which is an acid. Next, is the number they're giving us bigger or smaller than 10 to the negative 7? They have 10 to the negative 4, so we have fewer zeros in front of this number, which means it's going to be bigger. So bigger than 10 to the negative 7, right? Because 1, 2, 3, that, right? 1, 2, 3, 4, that's bigger than 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6, 7. Okay, so 1.4 times 10 to the negative 4th is bigger than 1 times 10 to the negative 7th, So we have more acid than neutral. More acid than neutral, that means that the solution is going to be acidic. So this is acidic. All right, C. First, are they giving us an acid or a base? They give us OH minus, that is a base. Second, is the number they're giving us bigger or smaller than 10 to the negative 7? Because the exponent is negative 12, that's going to have more zeros in front of it, so it's going to be smaller than 10 to the negative 7, which means you're going to have less. So this solution has less base than neutral. Because it has less base, it's going to be opposite acidic. So this solution is acidic. All right, for D. First, are they giving us an acid or a base? They give us OH minus, that means we're dealing with a base. Second, is the number they're giving us bigger or smaller than 10 to the negative 7? It is, the exponent there is negative 2, that means we're going to have fewer zeros in front of this, which means it's going to be bigger than 10 to the negative 7. If it's bigger than 10 to the negative 7, that means we're going to have more base. If we have more base than neutral, then the solution is basic. So here, for D, the solution is basic. So that's the thought process you want to go through with these. If you ever had a concentration that had 10 to the negative 7, for example, if you had H3O plus equals 4 times 10 to the negative 7, you would look at the exponent and you might be tempted to think, well, that is equal to 10 to the negative 7. But remember we're comparing this to 1 times 10 to the negative 7. If the exponent is the same, then compare the numbers in front. But always compare the exponents first. So only if the exponents tie would you compare those numbers in front, and the bigger one would give you a higher concentration. So that's the reasoning you can go through to determine whether these concentrations of H3O plus or OH minus are neutral, acidic, or basic.